This is a video lesson on metric relations in right triangles. So the setup is that if you have a right triangle which is cut through its right angle and which forms another right triangle, actually forms two other right triangles, because if this is a straight line, this must be a 90-degree angle as well. So by this setup, this triangle here, ACD or ADC, and this triangle CBD or CDB, and this triangle ABC, they're all similar. And because of that, you can set up certain ratios which lead to certain equations. So the most important thing is if you recognize this setup, if you see that there's a 90-degree triangle which is cut and which forms another 90-degree triangle, then you know that these relationships are all going to be true where this side, the line that cuts through the 90, the larger triangle, and which forms the 90, that's called H. And then these, the legs of the largest right angle triangle, are A and B, A being the smaller and B being the larger. And then the hypotenuse of the largest triangle is called C, and it is cut into portions M and N, where M is the larger of the two and N is the smaller of the two. If you want to pause, rewind, review that. But basically what I want to do is take any example and line it up with this one to name all of the sides A, B, C, M, N, H. And if that is true, these following things are necessarily true, that H squared is equal to M times N, A squared is equal to Cn, etc., and Pythag, which includes A squared plus B squared equals C squared, but also in this case that H squared plus N squared equals A squared, and that H squared plus M squared equals B squared. So anywhere that there's a right angle triangle, that Pythag relationship is in effect. So how do we use this? Well, in, let's say, this example here, find the length of segment QR. The first thing I would do is recognize there's a right angle triangle, it's cut through its 90, and it forms another 90-degree angle, and thus another one here. So what I will do is I'm going to take these labels, the A, the B, the H, the M, the N, and the C, and I'm going to try to apply them here. See if I can name everything the way I'm supposed to. So some of these might be easier to do than others. Like, I know that the H, for sure, is the line that cuts through that first biggest 90-degree angle. So I'll put that in right away. That H, that's this one here. That's my 6. Put that in here. Maybe I'll get a little bit smaller. It doesn't get in the way of stuff. That's H. And this, the entire length of S to R, that whole thing is C. I know that is maybe an easy one to find as well. I'll put in an arrow. And then of the two legs, that's QR and SQ, I know that the larger one is B and that the smaller one is A. So it doesn't matter which side it's on. It's not about right side, left side, or up or down. It's about which one is the larger of the two. It's relative. This one is the B. This one is the A. And similarly, of these two segments down here that have been cut along the hypotenuse of the largest triangle, M is the bigger portion and N is the smaller one. So this one here would be N, and this one here would be M. So how do we use that? Well, I can start by finding some missing values, even if it's not directly QR yet. Here what I have, and I'll usually write out a list of what I have. I know that H is 6. I know that N is 3. And so what I would do probably is look for a formula that has both H and N. And there is one. That is one that allows me to find M. So I can do that first. I can find M, because I know that H squared is equal to M times N. So I can plug in what I know. I know that H is 6. I know that N is 3. And when I solve for M, what I'm going to end up getting is 36 divided by 3. That means that M is 12. So I found one of them. M is 12. Now I know H, N, and M. And there's another relationship here, which is that M plus N is equal to C. That's just by the setup of what I have here, by the setup of the diagram. I know that the C is the entire length. That means that C here is equal to 12 plus 3. That's 15. I know that too. So what I'm looking for, QR, corresponds to B in my diagram. I can just use the formula. I have one like that. B squared is equal to C times M. And solve. So if I plug in all the values that I have here, I'm looking for this segment QR. That's the B in my diagram. I know that the value of C is 15. The value of M in the diagram is 12. So I can simplify. I'd have to take the square root to solve. And it turns out that the value that we're looking for is the square root. B is equal to plus minus the square root of 180. We know that it has to be positive because we're looking for a length. And I can reduce that and say that that's 6 root 5, and that is the most precise we can get and the most simplified that we can get, and that's the missing value.